You are losing marks in your Cambridge IGCSE Computer Science 0478 exam right now, and I bet you don't even realize it. Picture this. You step into the exam hall, you see a question on internet risks and safe use, spot a familiar keyword, and immediately write down the exact definition you spent hours memorizing. You feel pretty confident, right? But then results day arrives and you're sitting dangerously close to a lower grade boundary because the examiner capped your answer at just 1 or 2 marks. Why? Because Cambridge examiners aren't just testing if you can remember a word, they are testing if you can apply a digital mechanism to a highly specific scenario. Today, we are fixing this.
Look, here's the hard truth. We are replacing traditional memorization entirely today. Stop revising definitions and start solving digital problems. We're going to start with the anti-revision strategy, introduce you to a 3-layer framework, break down the rapid exam method, fix some flawed answers together, and then finish up with a foolproof final self-check. Okay, let's dive into this. Part 1, the anti-revision strategy.
Simply staring at flashcards and memorizing definitions is a massive trap. Ordinary revision completely fails under exam pressure because memory is fragile when it doesn't have any context. Instead, let's look at these common, painful, and entirely avoidable ways students throw away marks. The absolute biggest trap? Answering the wrong question based on a familiar word. You might see the word data and suddenly start writing an essay about memory versus storage when the question was actually asking about data handling and security in a network. Students also bleed marks due to vague wording, skipping crucial steps in a sequence-based process, or stating an advantage without giving any real reason. But the most fatal error of all is ignoring the provided scenario context. You might identify a device, but you leave it floating in abstraction instead of applying it to the exact situation the examiner gave you.
In just a moment, I'll show you the one specific examiner clue that changes an answer completely. It's a hidden trigger that turns a panicked, low-scoring guess into an automatic, full-mark explanation. But before you can actually use that clue, you absolutely need the framework that makes it blindingly obvious. Part 2, the 3-layer exam framework. To understand that hidden examiner clue, we use something called concept compression. This forces those massive, complicated topics from the communication and internet chapter through 3 very specific layers. Layer 1 is the simple layer. Explain the concept in everyday language as if you were literally talking to someone who has never touched a computer. Layer 2 is the technical layer. You swap out those everyday words for the correct Computer Science 0478 subject vocabulary. But Layer 3, that is where the magic happens, the exam layer. This is where the idea is shaped to actually score marks under time pressure. You see, students constantly trick themselves into thinking they know a topic because they mastered layer 1 or 2. But honestly, until you try to express it in that rigorous 3rd layer, structuring it as a sequence of operations or a security judgment, you just aren't ready for the exam. And this brilliantly illustrates the critical boundary between a safe but shallow low-grade answer and a top-band response. It's the fundamental difference between a description and an explanation. A description merely tells the examiner what the device, process, or method is. An explanation tells them exactly how it works and why it matters in that specific context. Examiners expect both. If you only describe, your answer is safe but shallow, earning maybe 1 mark. But if you jump straight into explaining without naming the core concept first, your response just sounds confused. You have to name it, describe it, and then explain its mechanism. Part 3, Rapid Exam Method Review. Now, we need a highly tactical approach to tackle any internet risks and safe use question. This disciplined path stops you from panic writing. Step 1, identify the demand of the question. Are they asking for a process explanation, hardware selection, or maybe an evaluation of alternatives? Step 2, classify the correct concept. Step 3, explain the sequence step by step. So many computer science topics are process-based, so ordering your steps logically prevents you from jumping backward and forward, which totally breaks the flow of your answer. And step 4, connect the explanation back to the context. Always double-check if your answer needs an advantage, a disadvantage, or a comparison to finish it off. Specificity is literally everything here. Generic responses rarely, if ever, gain full marks. Let's break down these examples. If the scenario is set in a school, writing "use a firewall" is a bad application. It's too generic. A high-mark application is filter-specific educational web traffic. See the difference? If the context is an office, don't just say "use passwords." Actually say "enforce logical security on employee accounts." In a retail environment, "keep data safe" gets you absolutely nothing. "Secure customer payment data" gets you the mark. Real-world transfer matters immensely because it converts your raw memory into actual scored usefulness. Let's move to and see how this builds in Part 4.
Fixing flawed exam answers. I'm putting you in the hot seat now. Here is a realistic Cambridge-style scenario. A school network faces an internet security risk. How do you protect it? I want you to mentally predict your answer right now. What device or software do you use? What is the actual mechanism? And how does it apply specifically to the school? Go ahead and lock in your answer. All right, let's compare what you thought of against these two potential responses. The flawed answer correctly identifies a security device, let's say a proxy server or a firewall, but it just defines it and stops cold. It leaves the idea completely floating in abstraction. The top-end answer, however, does the whole shebang. First, it names the concept clearly. Then, it actually sequences the mechanism, explaining that incoming traffic is checked against a set of predetermined rules. Finally, it applies it directly to the context, stating that this prevents unauthorized access to the school's internal student records. Now, what's really interesting about this breakdown is exactly why the top-band answer wins. It actively diagnoses what type of thinking is required, in this specific case, a security judgment. It cleanly separates the description of the device from the explanation of its mechanism. It explains the mechanism first and only then states the consequence, rather than getting tangled up in the reverse order. And most importantly, it maintains perfect clarity of sequence, literally taking the examiner by the hand through the logical steps. Which brings us to the payoff of our missing examiner clue. Here it is. If a concept can be paraphrased accurately, it is far more likely to survive in an exam hall. This is the ultimate secret, guys. True understanding means you do not rely on memorized wording. If you fixate on a keyword or a familiar symbol and ignore the deeper process, your answer completely shatters when the question wording changes even slightly. But if you know the core mechanism so well that you can paraphrase it accurately on the fly, your knowledge becomes bulletproof. Part 5. The next step to mastery. So the crucial point is this. Before we wrap up this explainer, I want to give you a practical tool you can use for literally any syllabus topic. It's a 4-step self-check. Number 1, what is it? Number 2, how does it work? Number 3, where is it used? And number 4, why is it better or worse than an alternative in that specific situation? If you can answer these 4 prompts aloud right now, without checking your notes, the topic is ready for the examination hall. But if you stumble, if you hesitate, or if you find yourself frantically reaching for a textbook definition, actually, scratch that. You need another full cycle of explanation and recall. Okay, so you now have the high-mark strategy for internet risks. You know the theory, the framework, and the traps to avoid. But a massive, glaring curiosity gap remains. How does this apply to evaluating automated systems and practical data analysis for fill marks? Mastering this theory inherently demands a follow-up skill, the exact practical and data analysis techniques that examiners use to separate the top grades from the rest. What to revise instead is in Video B. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click over to the next explainer right now, and I'll see you there.